As you may know, the ACT math increases in difficulty as you go through the section, and many students struggle when you get to those last 15 questions from questions 45 through 60, where the difficulty really increases, or the ACT tests you on more advanced topics. Now, many of these advanced topics, things like matrices, vectors, ellipses, law of sines, law of cosines, factorials, and there of course are many more, are challenging because you've never learned them in school. So in this video, I've chosen 12 of the most heavily tested topics that appear in the ACT all the time that are actually really easy to learn. So make sure you grab a pen and pencil, memorize all the equations I'm going to teach you in this video because it is going to help whether you're aiming for a perfect score or just trying to boost your math score quickly before this weekend. It will help you immensely on test day. Let's start with multiplying matrices. Matrices are one of those topics that many of you may have learned in school years ago or never learned at all, but the ACT absolutely loves to test you on it. And I can almost guarantee you're going to see a matrices question and likely a multiplying matrices question on your test this weekend. Now, how do we multiply a matrix? Well, first of all, we have to figure out the dimensions. Our first matrix here is a 2 by 2, so we write 2 by 2. Our second matrix is always is also a 2 by 2. So we check the middle numbers here, the middle numbers match, and we bring down our outside values, which tells us this is going to be a 2 by 2 matrix. It'll have 4 spots that we're going to fill in as we go. Now, with this one, it's a little more obvious. The answers all show that, but that method will be helpful in other matrices questions you may see on testing. Now, the way I like to teach this is, if we're multiplying a matrix, we work across the top matrix and down across the first matrix. So we're going to work across this first one and vertically down the second one. If we're going to solve for the top left spot, we're going to work across the top and down the left-hand side, then it's a little combination of multiplication and addition. We're going to start at the left and the top. We're going to multiply those values. So I get AE for my top left spot. Then we're going to shift to the right and shift down to our second pair of values, and we're going to add B times G. So we're going to take our first pair, A and E, multiply, we shift, take our second pair, multiply, and we add those sums together, which means what I get in the top left of my matrix should be AE plus BG. At this point, as you can usually do in the ACT as well, we can check the answer choices right away and already tell that our correct answer here is going to be C. Take a look on your own and see if you can figure out why all 4 of these other ones make sense with that same cross-down method. If you want to learn more about how to do this, you can check out the free trial of my Ultimate ACT course where I'll teach you everything you need to know about matrices. You can also see ellipses on test day. And for ellipses, even if you've never learned these before, all you need to know is our equation right here. So for an ellipse with the center at HK, the equation you have to memorize for test day is x minus h squared over a squared plus y minus k squared over b squared equals 1. Now, what this a represents here, you can think of as like the x radius. It's how far left or right the ellipse goes from the center. And the b is like the y radius. It's how far up or down it goes from the center. So we're going to use this question right here to kind of teach this. So we're given this ellipse. We can see the center of our ellipse is basically right here. So the center is going to be at the point 0, -2. The a value is how far left or right we go. So we can see this distance, how far left or right we go, is the a value here. Since we're going from 0, -2 to 2, -2, the a value is 2. And the b value is just how far up or down we go. So the b value here is going to go from -2 to 1. So the b value is 3. So we can use the answer choices, or we can write out the equation on our own. What we need here is x minus h squared. Well, it's just like x minus 0 squared. Oops, squared. Try that again. Divided by our a squared, which is 2 squared, plus our y minus -2 is plus 2 squared over our b squared, which is 3 squared, equals 1. And if we check the answer choices, x minus 0 squared is just x squared, our 2 squared becomes 4, and we can see here our correct answer is going to be C. Again, as long as you memorize this equation for test day, you'll probably be able to answer any ellipse question correctly. Logarithms also appear pretty regularly in the ACT, but it's a topic a lot of students feel like they didn't learn much in class or have forgotten. Now, a log is just a different way to write an exponential. So the basics we need to know with a log is kind of how to go in a circle. So here it's a to the c equals b. So log base a of b equals c is the same as a to the c equals b. With numbers, log base 3 of 3 is 1 because 3 to the first power is just 3. Log base 3 of 9 is 2 because 3 squared is 9. Log base 3 of 27 is 3 because 3 cubed is 27. So as long as you know to go in that circle, it's going to make it easy. Now I've got a great trick for you though, which is memorize this equation for testing, because it means you can actually plug, no matter what your calculator is, you can plug in any log question to solve it. So here, log base b of a is the same as if you press the button, the log button in your calculator, log of a over log of b. So if you see a question like this one down here, what is the value of 5 log base 2 of 8 minus 2 log base 9 of 3? Well, even if you have no idea how log works, all you need to do is do 5. We can find out with this in your calculator, because you can just make this log of 8 over log of 2 minus 2 times log of 9 over log of 3. So if we do that, log of 8 over log of 2, or log base 2 of 8, is going to be 3. So it's just 5 times 3. The reason it's 3, for those of you trying to kind of learn how this works, is this, just think 2 to what power equals 8? Well, it has to be 2 cubed. If we do log of 9 over log of 3, that's going to be 2. The reason is log base 3 of 9, just think 3 to what power gives me 9? That's 3 squared. So here it becomes 15 minus 4, which gives me an answer of 11. But again, as long as you memorize this equation right here, you can do it on your calculator even if logs are challenging for you. The ACT also loves to test you on advanced trigonometry. What I mean by advanced trigonometry is law of cosines and law of sines. These next two, you definitely have to memorize the equations, and you'll very likely see one of these somewhere from question 40 to 60 on your test this weekend. Now, law of cosines here is a squared plus b squared, a squared equals b squared plus c squared minus 2bc cosine of a. Sometimes they give this to you on the test in a note below the question, but usually they don't. So you got to memorize this for testing. The way this works, don't think of cosine as like SOHCAHTOA if you've never learned this before. Here it's just a rule for any triangle. So all you need to really know is that the A is the side length opposite the angle, and then the B and the C are interchangeable in the equation. There's the other two sides. So it could appear in a question like the one we see here. Which of the following equations, when solved, would give the value of x in feet of the missing side length of the right triangle below? So we're trying to find this side length here, but think which one is our opposite. So the opposite is going to be our 18, so that's going to be our A value. The x and the 21 are B and C, so it's just going to be 18 squared equals 21 squared plus x squared minus 2 times 21 times x times the cosine of 58 degrees. So all we need to do is check the answer choice and see which one matches. I wrote the 21 first, the x could be first. What I wrote is the exact same as what we see here in B, and that would be your correct answer. For law of sines, you have to memorize our equation right here, which is the sine of angle A over A equals sine of B over B equals sine of C over C. Again, this is for non-right triangles, so don't think of this as like SOHCAHTOA, like sine is opposite of hypotenuse. It's just a property. And again, notice here we're working in pairs. The sine of angle A over A is the same as the sine of angle B over B is the same as the sine of angle C over C. So we're looking for basically pairs of angles and opposite side lengths. So for a question like the one we see here, the figure below shows a drone. At a certain moment, the drone forms an angle of elevation 65 degrees from point A on the ground. At the same moment, the angle of elevation of the drone from point B 170 feet from A on level ground is 57 degrees. Which the following is closest to the straight line distance from B to the drone? So we're trying to solve for this distance here. I'll call this x. So we see, well, what are our pairs here? Well, we have one pair with 65 and x. The other one up here, we have 170, and we have a pair with this angle here. Now, the good news is, with this angle here, we can solve it because we know that all three angles in our triangle have to add 180. So this angle up here is going to be 180 minus my 65 minus 57, which gives us a value of 58 degrees up here. So we know that this angle up top is going to be 58 degrees. Now what we can do is we can use our equation. So we know that sine of angle A, say sine of 65 over x is equal to sine of angle B, sine of 58 over R170. We're solving for x here, so all I need to do is cross multiply and solve. So if I cross multiply, I get 170 times the sine of 65 equals x times the sine of 58. All we need to do to solve for x is divide both sides by sine of 58. And here the answers are numbers. It's got to go to the calculator. We can do 170 times the sine of 65 divided by the sine of 58. And we get a value of 181, which is basically 181.67, which rounds to 22. And the correct answer here of C. So again, both these last two topics, law of sines, law of cosines, really important to memorize the equations. You will very likely see one of these on test day. If you ever see a question with geometry and various units, such as here, we see a yard, the size of a yard given in feet and the area in square yards, you can use this one pro tip to get it right every single time. Always convert the units before finding the area or the volume. So here, we want to first convert our feet to yards. So 120 feet, 1 foot is the same as 3 yards. So we can divide that by 3, and it's going to give us 40 yards. And the length, 45 feet, if we divide by 3, is going to be 15 yards. Now, all we need to do to find the square yards is 40 yards long times 15 yards wide. And if we just do our 40 times 15, you punch in the calculator and you find the answer is going to be 600 square yards. The mistake everyone makes in these questions is they go, oh, it's 120 by 45, and that gives us an answer of 5,400 square feet, and then they just go, oh, I'm going to divide that by 3 because 1 yard is 3 feet, and they put D. Again, the ACT will always have that wrong answer for you. You can avoid that mistake if you always do what I just said. With our little pro tip is, again, always convert units before finding any area or volume. The ACT also includes questions on vectors, which is a topic many students have never learned before. Now here I'm going to show you how to do adding or subtracting vectors when they're drawn on the coordinate plane. So here, if I want to find out what f minus e plus a is equal to, we're going to start by drawing vector f. So vector f is going to go from the origin and go, of course, where vector f is. Then we're going to draw minus e. Well, we're going to start here at the end of the vector, and we're going to draw minus e. Regular e goes down 3, so this would be plus e. Minus 3 has to go the opposite direction. So minus e is going to go up here. So that's going to go minus e. And then to draw our next point, we're going to add vector a. So I'm going to start right here, and I'm going to draw vector a. We see vector a goes 3 to the right and up 2. So I'm going to go 3 to the right and up 2. And where I end up, if I kind of draw a little vector over here, we ended up, after all that drawing, we drew vector f. We did plus minus e plus a. We got here, if we draw from where we started the origin up here, this is going to be my f minus e plus a. You can see the point we ended at right here was basically 0, 2 on the coordinate plane. If I was going to write this in our standard vector notation, the I is like, the I's in the answer choices here, the I is like the x component, it's how far left or right we go. The j is the y component. So here, if it's going 0 left and right and up 2, the vector would be drawn as 2j, and the correct answer would be B. Now, if you've never done vectors before, I know that seems confusing, but I can teach you guys everything you need to know about vectors. That's all inside my Ultimate ACT course, or my entire ACT math course specifically, which I'll go through everything you guys need to know on vectors, and of course, everything you need to know on everything on the entire ACT. The course also includes a PDF copy of my 300+ page math book that's actually about to come out and be published, so you guys get a sneak peek at that as well if you sign up today. If you've never heard of factorial before, it's when we see this little exclamation point after a number. Now, technically, n factorial is defined as n times n minus 1 times n minus 2 all the way down to 1. Now, if that seems confusing, no worries. Let's use with some numbers. So as a simple example here, 5 factorial is 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. 10 factorial would be 10 times 9 times 8 times 7, all the way down to 1. So, knowing this will be helpful for both some easy questions in the ACT or a more advanced one like the one we see below. Which of the following is equivalent to 5 factorial over x minus 1 factorial divided by 3 factorial times x factorial? Well, let's write this out. So 5 factorial is the same as 5 times 4 times 3 times 2 times 1, and x minus 1 factorial is the same as x minus 1, and we subtract 1 each time, times x minus 2 times x minus 3, all the way down to 2 times 1. This is all divided by 3 factorial, which is 3 times 2 times 1, and x factorial, which is x times x minus 1 times x minus 2 times x minus 3, all the way down to 2 times 1. All right, so what cancels here? Well, we see the 3, 2, 1 cancels on the top and the bottom. And then with the factorial, what we see is, oops, I made one typo there. It should be x minus 1, not x minus 2. So the x minus 1s cancel, minus 2s, minus 3s, everything cancels except for the x right here. So all we're left with is the 5 times 4 on top, which is 20, and the x on the bottom. So that gives us our correct answer here of A. So again, this is a more advanced question, would appear towards the end of the ACT, but they also test you on way simpler factorial stuff where all you need to know is the little rule we saw at the top of the page. So make sure you understand what that exclamation point means if you see it on test day. On the recent ACTs in 2022, they'd love to ask you about finding the probability in a table like our example below. So say we're given this table about pizza. It says Max and Amelia are picking up 2 pizzas from Pete's Pizzeria for lunch. If 2 pizzas are randomly selected from the pizzas ordered from 1 to 2 p.m. at Pete's Pizzeria, what is the probability that Max and Amelia get 2 deep dish pepperoni pizzas or 2 thin crust cheese pizzas? So the table here is showing us the pizzas that were ordered from 1 to 2 p.m. So what do we have to do? Well, we want to find the probability of getting 2 pepperoni, or, which means we add the probability of getting 2 thin crust cheese. All right, well, let's think about what's the probability of getting 2 pepperoni. So if I'm going to pick 2 pizzas, let's start with the first one. So if I'm going to get a pepperoni pizza, sorry, a deep dish pepperoni pizza, that's what it says here. So this is a deep dish pepperoni pizza. So, well, I see there's 25 deep dish pepperoni pizzas, and I have to add up all of these to find how many total pizzas were made. Well, if I add those all up, I get to 80. So the probability of getting 2 deep dish pepperonis, the first one, is going to be 25 over 80. Now, once I've picked one pizza, if I'm going to randomly select a second pizza, there's only 79 pizzas left to pick from, and I've already picked 1 pepperoni, so it's going to be 24 over 79. When we have multiple events in a row with probability, we multiply those together. So that's going to be our probability of getting R, 2 deep dish pepperonis. Since it's an OR question, we have to count the 2 thin cheeses as well. So we're going to repeat that. The thin cheese pizzas, there's 12 to start. So the first one, there's a 12 over 80 probability of picking a thin cheese crust to start. Then, if we pick another one, there's now, again, 79 pizzas to pick from, and there are 11 here. So that's how we would set this up. All we need to do is check our answer choices here and see which one matches what we just found. And the correct answer here is going to be C. If the ACT really wants to stump you, they can put a repeating powers question on test like the one we see here. So if it asks you what is 7, or when 7 to the 217th is multiplied out, what is the digit in the ones place? A lot of students go, let me try in my calculator. It gives you an error message or gives you a number that's too big to tell, and we go, I have no idea how to solve this. Well, this is actually a repeating pattern. If we start doing the powers, 7 to the first is just 7. 7 squared is going to be 49. 7 cubed is going to be 243. 7 to the fourth is going to be, I think if I remember correctly, it's going to be 2,401. And then this pattern actually starts to repeat. 7 to the fifth power is going to be 16,807. If we keep going, we're going to see the units digits are going to repeat. It always goes 7, 9, 3, 1. 7, 9, 3, 1 over and over again. Well, how am I supposed to figure out what 7 to the 217th is going to be? Well, we see here every multiple of 4, like this would be 7 to the 8th, it's going to end in a 1. So all we need to do is find a multiple of 4 near 217, and then we can count forwards or backwards in the sequence. So to do that, what we can do is we can do 217 divided by 4 and see what we get. If we do 217 divided by 4, on calculator here, we'll get 54.25. We can round that to 54 and multiply by 4, and what that's going to tell us is a multiple of 7. So it tells us 216, sorry, not a multiple of 7, a multiple of 4. So it tells us 216 is going to be a multiple of 4. So what that means is 7 to the 216th power, since the multiple of 4, is going to be here in the sequence. It's going to end with a 1, which means 7 to the 217 is going to be the next one in the sequence. It's going to end in a 7, and the correct answer here is going to be D. So again, that is designed to be a huge stumper on the test, but if you see it on test, you remember this little repeating patterns trick, you'll be good to go. If you ever see any other powers, like maybe a 5 to a certain power, or 2, or a 4, or a 3, just start doing out the sequence. Most of the time, you'll see powers they'll put on the test will repeat in sets of 4, just like this one did here. You also need to know the discriminant rules for testing. Now, the discriminant is when we have our quadratic formula, which here you should absolutely memorize this for test day if you don't already have it memorized. The discriminant is this part underneath the square root, b squared minus 4ac. And the table here shows us the rules. If b squared minus 4ac is positive, that means we're going to have 2 real solutions. If it's equal to 0, we have 1 solution. And if it's negative, we have 0 real or 2 complex solutions. So if you see a question like this, which of the following most precisely describes the solutions to the equation 3x squared plus 5x plus 7, we just have to use our discriminant rules. Let's find the discriminant. So it's going to be b squared, which is going to be 5 squared, minus 4. Our a value is 3. Our c value is 7. Let's find out what that equals. Well, 5 squared is 25. 4 times 3 times 7 is going to be minus 84. If we do the math there, we get negative 59. Well, that means our value is going to be negative, which means we're going to have 0 real solutions or 2 complex solutions. Solutions is just another word for roots, or roots is another word for solutions, and our answer choice is here. So the correct answer here is going to be E. Again, this question might seem impossibly difficult until we know exactly how to solve it with this little equation we have here. So make sure you memorize the discriminant rules. You also need to have your special right triangles memorized. These questions are come up really anywhere in the ACT, but more likely towards the later, more difficult questions on the test. So our 45, 45, 90, remember the proportions are x, x, and x root 2 for the hypotenuse. If we have a 30, 60, 90 right triangle, it's x, x root 3, and 2x. So this could help us in a question like the one we see down here. It says a triangle has interior angles with measures of in the ratio of 4 to 8 to 12 if the shortest side of the triangle is 6 was the length of the second longest side. Now this question seems really confusing until we recognize this whole 4 to 8 to 12 can actually be simplified to 1 to 2 to 3, which is the same proportion of a 30, 60, 90 right triangle. So what we're actually given here is we're given a 30, 60, 90, not a very good triangle, try it again, 30, 60, 90 right triangle. We're told the shortest side is 6, so we know the hypotenuse is 12. The other one is going to be 6 root 3. The question says, what is the length of the second longest side? Well, here we can already tell, once we recognize it's 30, 60, 90, we know the answer is going to be A. Hope you guys enjoyed that video and learned a lot of important ACT math along the way. Please don't forget to like and subscribe. I'll have lots more ACT videos coming out, not only for the math, but the entire test. Let me know in the comments below if there are any topics we covered today you have more questions on, or if there are any topics that you've done in practice ACTs or you're studying that you want me to cover in future videos. Now, if you're really ready to boost your ACT math score, watching YouTube videos is probably not going to do it for you. You need a more organized way to prepare, so I highly recommend you check out our Ultimate ACT course. As I mentioned earlier, in the free trial, which has no credit card needed to sign up, there is an entire chapter of me teaching you everything you need to know about matrices on the test. In the full course, you get basically 15 to 20 hours of me going through and teaching you everything you need to learn in the ACT. It also has a PDF download of our ACT math book, which is soon to be published, so you can kind of get a sneak peek at that. The math book, again, will teach you everything you need to know for math in the ACT and has over 1,000 practice questions for you. So again, if you're interested in those, there are links in the comment and description below. Other than that, hope you guys enjoyed the video. Don't forget to subscribe. I'll see you guys next time.